Thirdly, when you check the pH, it's lower.
So Venus blood.
And CO2 is higher. Yeah. What vessel is used typically to check ABGs?
The radio.
Radial artery, that's correct. Okay. What do we call the outermost layer of the lungs? So I've heard a couple of answers. So you say parietal pleura. You say visceral pleura. All right, so the correct answer is the visceral pleura. All right, it is attached to the outermost surface of the lung, just like the visceral pericardium is the outermost layer, the epicardium of the heart.
So what is the parietal pleura?
That's not part of the lungs. That simply forms the outer layer of that sac, pleural cavity, the pleural sac, the pleural cavity. What is the specific name for the epithelial cells that line the visceral and parietal pleura? That's what I said. Mesothelium. Mesothelium. What type of epithelium is that? A mesothelium.
Simple squamous.
Simple squamous. Simple squamous. We're all breathing this atmospheric air here right now.
With the wasps.
Oxygen makes up what percent of the total gas content?
20%?
20?
21%?
21%. Yeah, I thought you said 20%. 21%. What is atmospheric pressure?
760.
760. Let's suppose Hunter's taking his test, okay? And all of a sudden, she realizes, I forgot to study.
No way.
And she begins to freak out and hyperventilate. What type of acid-base disturbance does she develop? Respiratory alkalosis. Respiratory alkalosis. Let's suppose that somebody develops an asthma attack. What type of acid-base disturbance? Severe asthma attack. They're using accessory muscles of inspiration and expiration. What type of acid-base disturbance would they develop? Right, because it wouldn't be ventilating, it wouldn't be moving air. So that would lead to hypercapnia. Hypercapnia is going to lead to a drop in pH. It's all starting to come together, isn't it? Okay. So let's give a scenario. Let's suppose I'm giving somebody supplemental oxygen because they're hypoxemic. So I'm using a venti mask with an FiO2, that's inspired oxygen content, of 30%. Okay. What type of PaO2 should that deliver? So go ahead and work that out. You may want to bring calculators for this test.
babysat five, I think he's 5. I babysat a 5-year-old this weekend that has asthma,
Uh-huh.
and he has an inhaler with like a tube on the end that's
Right.
supposed to make it easier, but it still was extremely difficult for him to do it because you have to get like someone to hold his nose and then.
Right, that's why in pediatrics oftentimes
The
they use a nebulizer
Yeah,
machine.
so that's what I asked the parents. I was like, I'd never seen that before, and they said he's going to like another specialist, so this is like temporary. Or
Right, they call it a spacer, but
Yeah.
but
it
typically they'll give a young kid a nebulizer
Yeah.
machine instead that they can just breathe
It was-
through.
Yeah, you have to like hold the mask on,
You-
like hold the kid down. and
Well, no,
then-
because it was like a tube.
Yes.
Well, the tube allows them,
Spacers work.
they don't have to exhibit the
It's-
lung-hand coordination, they
But
can
then
just
he
spray to the
didn't.
tube
Yeah,
and
but
then
then he
breathe.
kept trying to like talk while doing it, and I was like, can't do that. And then he didn't like that he couldn't breathe out of his nose. It was attack.
You wouldn't give us a specific PCO2 for that?
Let's suppose, it's 40. Any other data you need? Let me say this also, atmospheric oxygen is 160. Give you all kinds of data now.
Thank you.
That is perfect. He's so awesome about it.
Oh, y'all 82. Okay. Okay, so I mean, you can also. Have y'all come up with a number yet?
Is that 40?
Oh, PaCO2 is 40. I'm gonna ask one other question. So I want you to calculate the PaO2, and then I'm gonna tell you that the AA gradient is 10. Calculate the PaO2. All right, y'all should be done by now, huh? Brittany, do you know how to set up this equation? Not sure.
I know, you have to do 160 minus the 40.
Oh, come on up here, Sarah.
Well, I don't know the whole thing. 'Cause
Abby, you know.
I don't think I'm getting the right number. I'm messing this up.
Yeah, I don't think that mine would be right. 'Cause I thought-
I'm gonna say the math is very difficult.
Okay. So, let's see the PaO2. Okay? We want to calculate the partial pressure of the oxygen in the air that's inspired. Okay? Normally, we'd say 21% of atmospheric pressure is 160. So the partial atmospheric pressure of oxygen is 160. But then remember, when we inspire that air, we have to take into account water vapor, pressure created by water vapor. So we say 760 minus 47. And this is millimeters of mercury. Because the truth is that oxygen, that percent oxygen is really the percent of the dry gas mixture, not humidified. But instead of saying it's 21%, which is the content in the atmosphere, we're now giving 40% oxygen. So we'd multiply times 0.4. Okay?
Wait, I thought you were given 30%.
Oh, 30%, you're right, my bad.
Don't confuse me now.
Yeah. 0.3. I would have been wrong if I put 40. Okay. And then we have to subtract, once that mixture reaches the alveolus, oxygen is being pulled away, being consumed. Okay, and we know that the amount of oxygen is related to the ratio of PaCO2 divided by 0.8.
Right.
Where does the 0.8 come from? That's what confused me in the PowerPoint.
All right, so we're going to say it's 713 times 0.3 minus 40 divided by 0.8.
Wait, where did you get those numbers from?
The PaCO2 is 40 millimeters mercury. I gave that down here.
Okay.
And this is a constant.
All right, so you minus the 47 already?
Yes,
Yeah.
up here.
Okay. All right.
So it's 760 minus 47 is
It's
713
all right.
times 30% minus 40 over 0.8. So what's 0.3 times 713?
228. No. That was before the 43 millimeters.
What is it?
213.
All right, so 214. So it's 214 minus 50. That's going to be 164 millimeters of mercury. That would be your PaO2. Now, if you have a 10 millimeter mercury AA gradient, what's your PaO2 in the small case A? Yeah, you just subtract 10, so it'd be 154.
Okay, and why would you just subtract it?
Well, because I said your AA gradient. That's the difference in oxygen, the partial pressure of oxygen between the alveolus and the arterial blood. So if I know there's a 10 millimeter difference, I have to subtract 10 from 164.
Okay.
Now, oftentimes, the problem is that someone's in congestive heart failure, severe pulmonary edema, and they have an AA gradient of 60. And so in order to get adequate oxygenation into the arterial blood, okay, I have to give supplemental oxygen to counter the decreased diffusion of oxygen across that congested membrane.
What should the PaO2 be over?
Well, the PaO2 is usually around, normal is considered 80 to 100,
Okay.
okay?
Because you have to subtract that one, right? Sorry, focus.
How many molecules of oxygen can a hemoglobin molecule carry? 4, yeah. Now, answer this question. Percent saturation of hemoglobin is directly related to what? Percent saturation is directly related to, yeah, what do we call that relationship?
Dissociative,
Oxyhemoglobin dissociation curve.
yeah.
Okay, well, we have percent saturation and PaO2. The PaO2 relates to what? The amount of oxygen bound to hemoglobin, the amount of oxygen that's dissolved in plasma, or the total arterial content?
Dissolved oxygen.
No, it's just the amount of oxygen dissolved in plasma. Now, of course, the amount of oxygen dissolved in plasma will determine how much then binds the hemoglobin. So the higher the dissolved oxygen content, the more of an affinity oxygen has to hemoglobin. And the relationship is the sigmoid relationship. You know, it turns out that as one molecule of oxygen binds the hemoglobin, it increases the affinity for the next molecule of oxygen to bind. And when the second molecule of oxygen binds the hemoglobin, it still further increases the affinity for the third molecule. That's why you see this sigmoid shape, okay, instead of a linear relationship. Is that when one molecule binds the hemoglobin, it changes the shape of the hemoglobin molecule such that its affinity for the next molecule is increased. Hey, how you doing? We're just finishing up, what's out of time. Okay, now let's give this scenario. Someone has a hemoglobin concentration of 10 grams per deciliter, a PaO2 of, let's say, 90 millimeters of mercury, with an SaO2 of, I'm going to just say 100% to make it easy. I wouldn't make it 100%, but I'm going to say it.